I said 7.
Okay, so on our practice quiz, number 1, part A, how many possible outcomes are there? The bag contained 7 blue, 4 green, 6 red, and 8 yellow cards. So we combined those together by adding and said that that was 25 cards, so 25 outcomes. And for part B, and how many ways can choosing a card that is not red occur? If you do 25 cards minus the 6 that are red, that leaves you with 19 that are not red. And so we're going to write that as just 19. We're not going to write that as 19 25ths. It's not asking for the probability. So we'll just leave it as 19 that aren't red. Number 2. Number 2, order the events from least likely on top to most likely on bottom. We just said that 10% was the least likely of these 4. Scratch it out because we don't need it anymore. And that would be unlikely. You classify that as unlikely. You've got impossible, unlikely, as likely as not, likely, and certain as your 5 different likelihoods. Which of these is the next most unlikely? Caden? That's right, the 30% chance of rain. And Ella, if you had to classify that, would you say it's impossible, unlikely, as likely as not, likely, or certain? Yeah, it's still unlikely. It's 3 times more likely than the snow on Friday, but still unlikely. Okay. Now, the other 2 are not written as percents. And if you want to, you could write them as percents, and maybe that would help. On top, we have 4/5. What is 4/5 as a decimal? Thomas? You can use your calculator. How do you turn and this is for anybody while he's doing that, how do you turn a fraction into a decimal? Addison?
You divide the top by the bottom.
That's right, the top by the bottom. 0.8, okay, or 0.80. And when you slide the decimal over twice, what percent does that give you? 80%. Yeah. So 0.8 is the same as 80%. And then for this next one, it says a probability of 1. Well, slide its decimal over. It doesn't have a decimal, so just put 1 at the end. And what's 1 the same as? 100%. That's right. So we'd have to go with the 80%, which is the 4/5. And that was thunderstorms. And if you had to classify 80% or 4/5, what likelihood would you give it, Hannah? Raise your hand. Likely. Yeah, it's likely to storm on Wednesday. That leaves our last one with the temperature being greater than -20. So that's a 1 probability. That's as high as you get, 0 to 1, right? So 1's the highest you can get. And that was a 1 chance of the temperature being greater than -20 degrees Fahrenheit. And what do you call a probability of 1, Natalie? Certain. We are certain the temperature won't be, or will be, I should say, will be greater than -20 degrees. And that's number 2. Number 3. A spinner has 5 equal-sized sections of different colors. Hunter, what are those colors? Red, green, blue, yellow, and orange is exactly right. You spin the spinner 50 times. The results are shown in the table. Find the theoretical and experimental probability of spinning blue. We'll start with theoretical. Theoretical probability is based on what we know should happen. According to this spinner has 5 equal-sized sections. What should the probability of spinning blue be? Whitney? That's exactly right. 1/5. Do not look at the numbers to answer the theoretical probability. That's the experiment, right? We know that if it has 5 equal-sized sections, that getting blue is going to be just as likely as the other 4, and they all have a 1/5 chance of happening. So for part A, the theoretical probability is going to be 1/5. They all have a 1/5 chance actually, because they're all equally likely. For part B, the experimental probability is what actually did happen. This, Parker, when we were talking about like, I'd have to give you the data, this is where you'd have to use the data. There's no way to figure out the experimental probability unless you've already done the experiment. Okay, so when we look at this, yes. When you look at this, how many times did they spin blue? 15 times? Out of how many? 50. You could add them all up, but if you just read the instructions, they tell you that the spinner was spun 50 times, right? So 15 out of 50. That's the experimental probability. Now, what would that reduce by? 5. Okay. Andrea, how many times does 5 go into 15? And how many times does 5 go into 50? So this is going to reduce to the fraction 3/10. So again, just to clarify here, we're getting two different answers, and that's fine because the experimental probability probably won't be the same as the theoretical probability. Theoretical is what we know should happen. 1 out of every 5 spins theoretically should be blue. Experimental is what actually did happen. Blue is the number that was spun the most often. So they weren't all equally likely when we did it and tested it. Just like when we did the dice experiment. We knew for the dice experiment, it should be a bell curve, right? Did everybody, when we recorded our class, was it a perfect bell curve? No. When we combined our results with the other 2 classes, we got more of a bell curve. And I guarantee if I would have combined your results with all the results I've ever gotten with the dice experiment, it would be a really, really nice bell curve. Okay. So that actually answers part C of this question. What do you think would happen to the experimental probability when you spin the spinner 400 times? That's a lot more times. Would it stay the same, 3/10? Would it get farther away from the theoretical probability, or would it get closer to the theoretical probability? Anna? Closer to. That is exactly right. I guess we can just put closer. Okay. That's exactly what we just said with the dice. When you combine your results with everybody else's, and we end up rolling the dice at 1,730 sometimes, we got a really nice bell curve. Whereas if I just would have gone with Maddox's rolls and whoever Maddox partnered with, we're probably not getting a bell curve, right? But we combine the more results, the more trials we do, the more likely we are to get those results we'd expect. Okay. So it approaches, the experimental probability will start to approach. It's not going to stay. So right now we're at 1/5 is the same as 0.2. So we're at 20% right now. We have a 20% chance of getting blue, and then we actually got it 30% of the time, 3/10. And so what I'm saying is going to happen is if you roll 400 more times, it's not going to be 30%. It's going to come back down closer to what it should be. And the other numbers are going to come back up closer to what they should be, which is also 20%. Number 4, you roll a number cube and you flip a coin. How many events is this? 2. So when it says, what's the probability? I know that I'm writing my answer as a fraction. Well, actually, this one wants this percent, so we'll change it at the end. And so I need 2 fractions. Rolling a number cube and flipping a coin, independent or dependent? Independent. What you get on the number cube has no effect on what you'll get on the coin, right? In fact, if you rolled the number cube and then it said roll it again, would that be independent or dependent? It'd still be independent because what you get the first roll has no effect on what you'll get the second roll, right? To be dependent, something has to be taken out of or removed from the, like one of the numbers would have to fall off. I don't see that happening, right? So they're both independent. What's the probability of getting a number that's less than 5? How many of the numbers on this number cube are less than 5, Hannah? What are they? 1, 2, 3, and 4. Exactly. So you have a 4 out of what chance? Or 6 numbers. You have a 4 out of 6 chance of getting a number that's less than 5, getting a 1, 2, 3, or 4. What about flipping heads on the coin? 1/2. That's it. This is compound probability. Okay. Hunter, what cancels here? 4 and the 2. Okay, what goes into both of those? Okay. So 2 goes into 4 twice and 2 goes into 2 once. Okay, so looks like we're, oh no, we can actually still cancel. I see something else. Sierra, what do you see? The 2 and the 6. 2 goes into 2 once and 2 goes into 6 3 times. I think we're finally ready to multiply. Addison, on top, what is 1 times 1? 1. And on bottom, what is 3 times 1? Say it again. 3. There's our probability. 1/3. That's a pretty simple problem, right? Just multiplying 2 probability fractions together. Now, it wants our answer as a percent. I would be fine with this answer of 1/3 because that's accurate. It wants our answer as a percent. So how do you change a fraction to percent, Lucas? Yeah, change it to a decimal first. Top divided by bottom. Lucas, what is 1 divided by 3? Huh? Even though I told you to grab a calculator? You better go get one. Really, what's 1 divided by 3? Yeah, the 3 is going to go on forever. So when I move the decimal twice, because you still have to do that to change it to percent, 1, 2, we're going to put that 3 there, and there's going to be another 3. In fact, there's an infinite number of 3s after the decimal point still. So it's 33%, but there's more to it. 33.3 repeating percent. But it says write your answer as a mixed number. Well, what did we just say 0.3 repeating was as a fraction? 1/3. So 33 and 1/3%. It's kind of a weird problem because the 1/3 fraction is actually still in the percent. 33 and 1/3 if you write it as a mixed number. Now, and 33.3 repeating is fine. It's just Big Ideas doesn't have an option to write a repeating decimal. So you have to turn it to a fraction. We should know that 0.3 repeating is 1/3. What's 0.6 repeating? 2/3. Those are the ones you should probably know. We've done them a lot this year. All right, number 5. A brother and sister are in the same math class. There are 8 boys and 10 girls in the class. 1 boy and 1 girl are randomly chosen. What is the probability that the brother and sister are chosen? Write your answer as a fraction in simplest form. Now, I'll be honest with you, this question first confused me. I thought when it said 8 boys and 10 girls that there were 18 students in the class, which is correct. And I thought that he was wanting to know the probability of the boy being chosen out of the class and then the girl being chosen out of the remaining class. And if that were true, it'd be dependent. But then I looked at the question again. It says 1 boy will be chosen and then 1 girl will be chosen. So they're not drawing them out of the entire class. He's divided the class into the boys and girls. He's drawing from the boys group and then drawing from the girls group. Does this make sense? Does who he draw from the boys, does who the teacher draws from the boys group affect who can be drawn from the girls group? So is this independent or dependent? This would be independent for that reason. So when he draws out a boy, what's the probability that that brother gets chosen? 1 out of 8. Yeah. See, in my mind, I was doing 1 out of 18, but that's not what the question's asking for, although that would make more sense in my mind. So 1 out of 8. And then what's the probability that the sister gets chosen? 1 out of 10. So even though there's 1 less girl, or sorry, 1 less boy in the room, it didn't affect the fact that he was still drawing a girl from the 10 remaining girls. That's why this is independent. What's 1 times 1 on the top and 8 times 10 on the bottom? And that's our answer. That doesn't get any more reduced than that. You already got a 1 on the top. Number 6. 10 tiles are numbered 1 through 10 and placed in a bag. You randomly choose one of the tiles. Without replacing the first tile, you randomly choose a second tile. Find the probability. Okay, so probability, I'm writing my answer as a fraction. How many fractions do I need? 2. Why? Yeah, I'm drawing 2 times. Exactly right. I need 2 fractions because I'm drawing 2 numbers out. Am I putting the number back in? No. So what kind of probability is this? Dependent probability. what I draw the first time is going to affect what I draw the second time. And if for no other reason, for the fact that there's one less tile in the bag, right? That probability is not going to be out of 10 again. What's the probability of choosing a 4? I'm going to go ahead and just number them. I guess you don't have to. But there are your tiles, 1 through 10. How many 4s are up there? Out of? Okay, so that's pretty simple. Now here's why I thought that might be helpful to number them though. The 4 is no longer there. Keep that in mind. So when it says then an even tile, how many of these numbers up here are even? Well, there are 5 of them, but yes, 4. 5 of them, 2, 4, 6, 8, and 10. But one of them was just removed from the bag. Which one? The 4 that you just drew out. So not only is there one less tile in the bag, so it's out of 9, but there's one less even number up there. You already drew the 4 out. So you had a 1/10 chance of drawing the 4. And then now you have a what chance of drawing the even number? 4 9s. Yes. Dependent events will always lower the denominator by 1. Think of our dice, think of our game with the dice where we went around and drew the red dice out of the bucket. Every time you didn't put the dice back, I had to drop the denominator by 1. That's really the main difference between an independent and dependent event when you're finding probability. Does anything cancel here? The 4 and the 10? Okay, 4 goes into, oh, wait, is it? 2 goes into 4. There we go. 2 goes into 4 twice, and 2 goes into 10 5 times. That sounds better. On top, what's 1 times 2? 2. And on bottom, what's 5 times 9? So it's dependent and it has a probability of 2/45. No number 7. There's only 9 questions. I took number 7 off because it wasn't related to what we were doing. Number 8. A store hands out 900 reward cards. Customers scan their cards in the store to find out what reward they receive. The probability that a customer receives a $25 gift card is 1/12. How many customers receive the $25 gift card? This isn't a probability question. They're not asking us for the probability. I already know it's 1/12. They're asking us to find the number of people that are going to win the $25 gift card. This is a prediction question. How do you solve a prediction question? There could be some dividing. There could be some multiplying. But what do you have to do before you do that, Natalie? There's 900 cards that are going to be given out to 900 customers. Yeah. What do you have to do first? Not yet. I want something. I want something first before we do any multiplying or any dividing. I want to write something down first. You're making a prediction. You're making a prediction. You're going to need a Aiden proportion. Yes, you're going to need a proportion for this, and that's going to be how you show your work on your quiz tomorrow. Okay. A proportion has 2 ratios. The first ratio is always going to be our probability ratio. The probability of 1/12 means that theoretically 1 out of every 12 people are going to win, right? So if 1 out of every 12 people will win, then fill in the blanks. It's out of 900. X over 900. We don't know, right? We don't know. If 1 out of every 12 people win the $25 gift card, yeah, don't get caught up in the 25. That's just what they're winning, the $25. If 1 out of every 12 people are going to win, how many, it says, how many is that out of the 900? And so we can cross multiply this. What's 12 times X? Good. What's 1 times 900? And so ultimately you end up just dividing 900 by 12, which I know that's what some of you were going to say to do, but I wanted to see your full work. What is that, Branson? X equals 75, and we'll put, it says how many customers? So customers, 75 customers are going to win that $25. There is another way. Now, I'd be perfectly fine on your quiz tomorrow with you doing this second way. The other way involves us using a decimal and just multiplying. No dividing at all. Well, actually, there is some dividing. The dividing happens when you change the fraction to a decimal. So the probability fraction of 1/12 as a decimal, 1/12 or 1 divided by 12 is 0.083 repeating. You can take your probability decimal of just over 8% and multiply that to the sample of 900 cards. Times that by 900, and you get 75. So there's another way you could do it. Just have to show your work. Either set up a proportion or show me that you're multiplying the decimal, probability decimal, to that 900. Yes. That's fine. I like the proportion because I want you to know why we're doing 900 divided by 12. It makes sense when you cross multiply that, that's what you end up doing, right? Yeah. And to me, the proportion is more intuitive. Like it makes sense that I would say 1 out of every 12 win. So how many out of 900 will win? Like it makes sense to set that up and then I can see the cross products happening. Number 9, a cell phone company tests 110 cell phones and finds that 4 of them have defects. Out of 550 cell phones, how many would you expect to have defects? How many? This isn't a probability problem where I write it as a fraction. How many cell phones will be defective? This is another prediction question. So far, how many cell phones have I seen with defects? 4 out of. So if 4 out of 110 are defective, then fill in the blank. How many X out of 550? And you could cross multiply this one, but mental math is actually going to be much easier. Can anyone tell me what they're multiplying 110 by to get 550? 5. Yeah, so you don't have to cross multiply if you see the mental math. What's 4 times 5? 20. So X is 20. And so we can put 20. I'd prefer not to put cell phones. We'll put 20 defects. Because there's actually 550 cell phones, but 20 defective cell phones. Frank? Wait, one more question. Now, there is a slight difference between the last 2 questions. This question here was a theoretical probability. So when I said make a prediction and we got 75, that really wasn't a prediction as much as it was a fact. 75 people will win. There are 900 cards. 75 of them are $20 gift cards. That's how you get the probability of 1/12. 75 people are going to win the $25 gift card. I know it for sure because that's how many cards were there. Okay. That was a theoretical probability. This is experimental. Like this is going to change. In the next shipment, I may not see any defective cell phones. And so the experimental probability will decrease a little bit. But this is what I've seen. That's why it says, how many would you expect to have defects? Because this really is a prediction based off of what I've seen so far. Whereas the last question said, how many customers will receive it? It's because 1 out of every 12 cards was a $25 gift card. And out of 900, that means there was 75 of them. So I guess you would treat the problem the same way, but that's the difference between knowing for sure how many people are going to win versus not really knowing how many. I'm making a prediction. I think there will be 20 bad cell phones out of 550 just based on what I saw in the first shipment. Our last question, number 10, says in each round of a game show, a contestant answers a multiple choice question that has 3 answer choices. The contestant advances to the next round by answering that question correctly. What is the probability of advancing to the 7th round if the contestant randomly guesses on every single question to get it right? Write your answers a fraction, simplest form. So every round I answer a question, and that question has 3 answer choices. If I get it right, I move on to the next round. How many questions would I have to answer right to make it to the 7th round? That gets me to the 8th round. 6. Okay, see why it's 6? I just want to get to the 7th round. I'm not actually guessing yet on the 7th round. So there are 6 questions, and how many fractions will I need then? 6, 1 for every question. I'm guessing on every single one of them. Every question that I'm guessing on has 3 answer choices. What's the probability that I get the first answer right? 1 out of, has 3 answer choices. 1 out of 3. Now, can I get the first one? Now, I know that I couldn't move on in the game if I got the first question wrong, but could I guess A on question 1 and still guess A on question 2? So is this independent or dependent? This is independent. In fact, the probability of getting the second question right is also 1/3 and 1/3 and then 1/3 and 1/3 and 1/3. So I know on top I'm getting a 1. If you don't want to do 3 times 3 times 3 times 3 times 3 times 3, you could just do 3 to the 6th power. I showed you yesterday how to do that. 3 to the 6th power is what? That's right. So you'll have a 1 out of 729 chance. All right. I will take your papers on the way out, and you guys are dismissed. I'll see you tomorrow for your quiz. Also, make sure you've been surveying your people.